Welcome to the deep dive. We cut through the noise, give you the essence of what you need to know. Today, we're tackling something pretty much everyone bumps into in the cloud, just information overload. You've got so many services, right? So many moving parts generating data. How do you keep track? How do you react instantly without just drowning? So this deep dive is all about Azure Event Grid. It's designed to be like a central nervous system for all those cloud events. Our mission today: unpack what it is, how it helps you build genuinely responsive, cost-effective architectures, and crucially, what are the key decisions you're going to face when you actually build with it? We've gone through a lot of comprehensive sources to kind of give you the shortcut here. And the big idea, the real shift it brings, it moves us away from that old, inefficient way of constantly asking, everything happened yet? Polling. Moves us to a much smarter, event-driven model. Saves resources, boosts responsiveness. It's quite a change. So, okay, starting there. What is Azure Event Grid, fundamentally? And why is it such a big deal for building modern apps?
Right, so at its core, it's a highly scalable, fully managed service for distributing messages. Uses the publish-subscribe pattern PubSub. You can think of it as the eventing backbone for Azure. Its main job is routing events efficiently, reliably from, well, loads of places, Azure services, your own apps, external sources, getting them where they need to go.
Okay. And that problem you mentioned, the polling one, that really is everywhere, isn't it? Traditional systems, they're always asking, hey, did anything happen? Did anything happen now? Like knocking on a door over and over. It's just
Right.
super inefficient. How does Event Grid actually fix that?
Yeah, that's the key difference. Event Grid just eliminates that need for constant checking. Instead of your services polling, Event Grid activates them, but only when an event actually happens, on demand. And that leads directly to, well, significant cost savings. You're not paying for idle compute cycles, just checking for updates. Plus, your system responsiveness shoots way up because handlers get triggered almost instantly. And it enables this elastic scaling resources spin up when there's a burst of events, scale back down when things quieten. Perfectly aligns with, serverless thinking.
Makes sense. And beyond just stopping the polling, you mentioned it supports different protocols, different delivery models, MQTT for IoT, HTTP, push and pull. How does that flexibility help in practice?
Oh, absolutely. That versatility is a huge plus. For IoT, you've got really extensive MQTT support versions, 3.1.1 and 5.0. That's critical for that two-way communication you need in IoT. Things like wildcard topics, the PubSub model itself, cloud integration. It's all there. Plus solid security, fine-grained access control, standard auth like X.509 certs, Entra ID, OAuth, JWTs, TLS encryption, obviously. You can even use custom domains for MQTT endpoints. Then for more general eventing over HTTP, you get this choice: push or pull. Push is where Event Grid sends the event to your subscriber endpoint, like a webhook. Pull is where your application actively asks Event Grid, hey, got any events for me?
Right. And that choice, push versus pull, that sounds like a pretty fundamental architectural decision. What drives that choice?
It absolutely is. It's critical.
Ugh.
Push is simple, right? You get notified immediately. But your endpoint has to be always available, publicly reachable. That could bring security headaches or maybe back pressure if your consumer gets swamped.
Yeah, I can see that.
Pull delivery, though, puts a consumer in charge. Your app pulls events when it's ready, at its own pace. So it's much more resilient if your app has downtime or needs to throttle processing. And a really key point, Pull supports private links, so you can keep all that event traffic inside your Azure private network. Big security win.
Ah, okay.
So you really need to weigh things up. How stable is your consumer? What are the security needs? How does it process events? For critical stuff, sensitive data, Pull with private links is often the safer, more controlled bet. For simple webhooks, maybe triggering a quick serverless function, Push is often fine and very efficient. Having both options is powerful, but yeah, you need to choose wisely.
Okay, that makes sense. Now, thinking about building really robust enterprise systems, reliability is just non-negotiable. How does Event Grid make sure events don't get lost? How does it handle failures gracefully?
Right. And Event Grid is really built for that kind of enterprise reliability. It takes a lot of that burden off the developer. You don't have to build all the complex, error-prone retry stuff yourself nearly as much.
Yeah.
The platform handles a lot. First off, it's built to scale dynamically. We're talking potentially millions of events per second, low latency. So events get moving fast. Crucially, it guarantees at least once delivery. So an event will get to its subscriber. Might be more than once in rare failure scenarios, but it won't be silently dropped.
At least once, yeah. Important distinction.
Definitely. And for push delivery, there's a built-in retry mechanism that runs for 24 hours, uses exponential backoff so it doesn't hammer a struggling endpoint. You can even configure the duration, the number of attempts.
Okay.
And if, after all that retrying, an event still can't be delivered, it goes to a dead letter location, usually that's an Azure storage blob container, this is your safety net. Undelivered events aren't just lost, they're stored, so you can investigate, maybe reprocess them later. Prevents data loss.
I remember a project years back. We built our own retry logic. Oh man, the operational pain, the debugging, it was rough. Having that built in sounds like a huge relief.
Exactly. Because in any distributed system, you will get transient failures. It's just a fact of life. Building your own bulletproof retry logic, it's hard, really hard to get right in all edge cases. So Event Grid's at least once guarantee is foundational. The exponential back-off is smart gives consumers time to recover. And dead lettering. It's the ultimate fallback. Preserves the event, doesn't just drop it. Vital for auditing, compliance, figuring out what went wrong, maybe reprocessing. It just massively lowers the complexity and operational cost of building reliable, event-driven apps.
Okay, so to really get a grip on this, let's break down the fundamental pieces. If you're tracking things happening in your system, what are the core concepts? How do they fit together?
Yeah, good idea. There are 5 key things. First, obviously, the events. That's just what happened. A file uploaded, an order placed, whatever. A notification of a state change.
Simple enough.
Then, the event sources. That's where it happened. Could be an Azure service like blob storage. Could be your own custom app, maybe a SaaS partner.
Got it. Source.
For events to go anywhere, they need to be sent to topics. A topic is basically the endpoint where the publisher sends its events. It groups related events, like you might have a new photo uploaded topic.
Like a channel.
Exactly, like a specific channel. Then, once events hit a topic, you need event subscriptions. This is how you route events to where they need to go. And this is where filtering comes in. You can say, I only want events about photos tagged nature, for instance. It directs the traffic.
Okay, so subscription filters and directs.
Right. And finally, the event handlers. These are the actual things that react to the event. Could be an Azure function that resizes the photo.
Yeah.
A logic app that sends an email. Whatever service needs to do something based on that event. They all work together. Source sends event to topic. Subscription filters and routes to handler.
Okay, that clarifies the building blocks. So with those pieces, what kind of things can you actually build or solve using Event Grid? What are the big use cases?
Right, this is where you see its real power. Event Grid isn't just, a simple message queue. It's more like a lightweight orchestration layer, a decoupling layer. It routes events from A to B without A or B needing to know much about each other. That loose coupling is just gold for modern scalable systems.
Can you get some concrete examples?
Sure. A classic one is serverless application architectures.
Right.
You upload an image to blob storage. Event Grid immediately triggers a serverless Azure function to, say, run analysis on it.
Yeah.
Super fast, super efficient.
Right, the immediate reaction.
Exactly. Then there's operations automation. Imagine a new virtual machine gets created. Event Grid can fire off an event to Azure Automation.
Yeah.
That can then automatically check if it meets compliance rules, apply necessary tags, maybe create a work item in your tracking system. Huge for governance, security hygiene.
Yeah, automating that toil.
Totally. And finally, application integration. Event Grid can be the glue between different apps. You can have your custom app publish its own events to a custom topic. Or you can hook it up with Azure Logic apps to process events without writing code connecting different systems together. So you see, it lets you chain actions, trigger parallel work across different independent parts of your system without those parts being tightly wired together. Really fundamental for building resilient, maintainable microservices.
You mentioned filtering earlier and also custom topics and event domains. It sounds like there's a way to manage the flow and maybe avoid chaos when you have lots of events. How does that work, especially in a bigger company?
Yeah, that's a really important aspect. The advanced filtering is great for efficiency. Handlers only get the events they actually care about. Saves compute, saves cost. Now, custom topics are perfect when one system or team owns the events. They create their topic, publish to it. Simple. But in a large organization, you could end up with hundreds of these custom topics. It becomes hard to manage, hard to discover what's available. That's what we sometimes call event sprawl.
Right, sounds messy.
It can be. That's where event domains come in. Think of a domain as a management container for a whole bunch of related topics, usually within a single Azure tenant. It lets you centralize publishing and, crucially, manage access control for potentially thousands of topics relevant to different teams or applications within that domain. So One team might manage the domain, but different teams can subscribe to specific topics within it based on permissions you set up. It really tames that complexity, improves governance, makes it easier for consumers to find the events they need. It addresses that enterprise scale challenge directly.
Okay, that makes sense for large setups. What about security and playing well with others, interoperability? What's the story there?
Security is pretty robust. You've got authentication options like X.509 certs, Microsoft Entra ID OAuth 2.0 JWTs. Communication is secured with TLS 1.2 and 1.3. And as we mentioned with MQTT, you could use custom domain names for namespace endpoints, which helps with security posture and client config. Now, interoperability. A key point here is the event schema. You actually have a choice. There's the Cloud Events v1.0 schema, and then there's the native event grid schema.
Okay. Why two? Doesn't that add complexity? What's the strategy behind offering both?
It's a fair question,
Yeah.
and I think it shows Microsoft making a very deliberate strategic choice, balancing things out. Cloud Events is an open specification, CNCF standard. By supporting it, Microsoft is signaling, hey, we play well with others. It's great if you're building multi-cloud solutions or hybrid ones. Makes integration with non-Azure stuff easier, reduces that feeling of vendor lock-ins.
Okay, the open standard route.
Exactly. But then you have the native event grid schema. This one is proprietary, yes, but it's optimized for working within the Azure ecosystem. It offers tighter integration, maybe simpler tooling in some Azure-specific scenarios. So they're giving you flexibility. If broad interoperability and future portability are your main concerns, you probably lean towards cloud events. If you're deep in Azure and want the most streamlined experience within Azure, the native schema might be simpler initially. The key is to think about it and choose deliberately up front. Trying to switch schemas later, that can create what people call schema debt. It gets messy and expensive to fix.
Right, technical debt around schemas, got it. So events get routed, great. What about actually processing them? And I've heard this term anti-corruption layer used sometimes with event grid and functions. What's that about?
Yeah, so the event handler does the processing. And Azure Functions are like the go-to service for this. They integrate really smoothly. Now, the anti-corruption layer, it's a pattern, really useful in distributed systems, especially complex ones. Now, imagine you have events coming from lots of different sources. They might not all use the same format. Maybe some data is inconsistent or doesn't quite match what your core system expects.
Okay, messy inputs.
Exactly. The anti-corruption layer, often implemented in that Azure Function Handler, acts as a translator or a gatekeeper. Event Grid delivers the raw event. The function then validates it, maybe transforms the schema, enriches the data, cleans it up, before passing a nice, clean, consistent event downstream to your core logic or other services. It protects your core domain model from getting corrupted by messy external data, ensures data quality, makes downstream processing simpler, and lets different systems evolve more independently.
Ah, I see, like a buffer and translator.
Precisely. And by the way, when you do use functions, definitely use the specific event grid trigger, not just a generic HTTP trigger. The event grid trigger handles validation automatically, and it does this clever rate matching thing to avoid overwhelming your function if there's a sudden flood of events. Plus, you can enable batching on the subscription for better throughput.
Good tip. Okay, this all sounds incredibly powerful, but you mentioned earlier there are two tiers, standard and basic, and you said it's not just about speed. What are the real differences? Why choose one over the other?
You're right. It's much more than just speed or throughput, although that is different between them. It's a really fundamental architectural choice because key features are tied to specific tiers.
Ah, okay. Like what?
Well, for instance, MQTT support. That's only in the standard tier. Yeah. Same for pull delivery, the model where the consumer pulls events. Only standard. On the other hand, if you want to subscribe directly to events from Azure services themselves, like that blob storage example, or resource group changes or events from partners, or use event domains, that's currently only available in the basic tier.
Oh, wow. Okay, so you really need to know what capabilities you need.
Exactly. So a simple webhook reacting to a blob being created. Basic tier might be perfect and more cost-effective. A complex IoT solution needing MQTT and maybe pull delivery for back-end processing, you need the standard tier. And the pricing model differs too. Standard has these throughput units you pay for hourly on top of operations. Basic is purely paper operation after the free tier. So you absolutely have to map your required features and expected volume to the right tier. Getting it wrong means either paying for stuff you don't need or worse, finding out you can't actually build what you intended.
Right, got it. Avoid unpleasant surprises. Speaking of cost then, Event Grid uses that pay-per-use model, which sounds fair, But you hinted there's a catch, something that can really inflate the bill if you're not careful.
Yes.
Yeah.
This is super important and honestly easy to miss if you're just scanning the pricing page. The charges are based on operations. But here's the kicker. An operation is defined as a 64 kilobyte chunk of data.
64K.
Yeah. So if you publish an event that's, say, 100 KB, that's not one operation. It's billed as two operations. A 256 KB event, that's 4 operations.
Whoa. Okay, that could add up fast if your events are chunky.
It absolutely can. It means you really need to think about optimizing your event payloads.
Yeah.
Don't stuff huge amounts of data into the event itself if you can avoid it. The best practice is usually to put just the essential info, the metadata, in the event. Then include a reference, like a URL, pointing to the full data stored somewhere cheaper, like blob storage. The handler can then fetch the full payload if needed. That reference pattern can save you a lot of money on Event Grid operations costs.
That is a massive aha moment on cost. Okay, so breaking out the actual tier pricing, bearing that 64 KB thing in mind.
Right. So standard tier. You pay for throughput units, or TUs. Each TU gives you capacity, like handling 10,000 MQTT clients, and costs about $0, 4 cents per hour per TU. You can scale these TUs up. Then you pay for operations on top. MQTT operations are about 1.50 per million. Event operations publishing, delivery attempts, certain filtering, dropped messages, even MQTT messages routed internally. Those are 0.60 cents per million. You do get a free monthly allowance. 1 million MQTT ops, 1 million event ops, and 7 days of retention are free.
Okay. And basic.
Basic tier is simpler. No TUs, it's just operations, priced at 0.16 per million. That covers published events, delivery attempts, advanced filtering. The free tier here is smaller, 100,000 operations per month, and retention is only 1 day free. So you can see higher event volumes and especially larger event sizes because of that 64 KD rule directly push up costs on both tiers, but the structure is different.
And the free allowances help, but yeah, you need to model usage past that.
Definitely. And remember, things like subscription-type government clouds might have different pricing, and always check the Azure pricing calculator for your specific region and currency. It's the source of truth.
Okay, so let's try and wrap this up. Azure Event Grid. It really feels like a foundational piece for building modern reactive stuff in the cloud. Its core strength seems to be that highly scalable managed pub-sub model. Getting rid of polling. That drives down cost, bumps up responsiveness. Huge win.
Absolutely. And the flexibility is key, too. MQTT for IoT, HTTP with both push and pull delivery. That gives you options.
Right. And the built-in reliability, the retries, the dead lettering, taking that burden off developers, that's massive for building robust systems. Ensures that at least once delivery without you having to sweat all the details.
Yeah, shifting that responsibility to the platform is a major benefit.
Then you've got the smart routing and filtering, plus custom topics in those event domains for managing things at scale, handling that potential event sprawl in big organizations. Lets you control the flow, govern access.
And the security features, combined with that strategic choice between open cloud events and the native Azure schema, it shows a good balance, I think. Interoperability versus deep integration.
And using functions as that anti-corruption layer, validating, transforming events, crucial for keeping data clean in distributed systems, letting services evolve independently.
Definitely helps maintain sanity.
And finally, cost. That paper operation model seems straightforward, but remembering that 64 kilobyte billing chunk is absolutely critical for optimization. Avoid those surprise bills.
Huge takeaway, that one.
And understanding the difference between standard and basic tiers isn't just about speed, it's about core features, MQTT, pull delivery, system event subscriptions. Making the right tier choice up front is vital for both function and cost. Couldn't agree more. So hopefully this deep dive gives you the knowledge you need to think about how Event Grid could fit into your world, building more resilient, scalable, cost-effective solutions, letting you focus more on your actual business logic, less on the plumbing. Which leads to a final thought for you to mull over. Considering how Event Grid can streamline communication, simplify things. What's a complex, maybe always-on, polling-heavy problem in your work that could potentially be reimagined, simplified, optimized if you started thinking in terms of reactive events instead? Something to chew on. We encourage you to explore Event Grid further. Maybe spin up a quick prototype, map out a potential flow, see what it can do for you.